Welcome to The Explainer. Today, we're unpacking a hidden thermodynamic rule that literally orchestrates every physical, chemical, and biological movement in the cosmos. It's basically the invisible maestro conducting the entire symphony of the universe. And I promise you, once you see how it works, you're never going to look at the world quite the same way again.
Okay, let's dive right into this. Think about it for a second. What connects your smartphone, a massive rainstorm, and the very heartbeat keeping you alive right now? At first glance, a piece of cutting-edge tech, a meteorological event, and biological rhythm seem to have absolutely nothing in common, right? They operate on totally different scales. But there's actually a massive central mystery linking all these completely unrelated everyday phenomena.
Well, the answer to that mystery is something called chemical potential. It is the ultimate hidden force driving absolutely everything in our universe to maximize entropy and seek natural balance. Whether we're talking about a terrifying weather system or just a single solitary atom, nature absolutely abhors an imbalance. Chemical potential is the master thermodynamic metric that dictates exactly how, when, and why matter moves to fix that imbalance. Now, don't worry, we aren't going to define this as some dry, complex math equation. Instead, I want you to picture chemical potential as a dynamic, invisible pull. It's the innate, thermodynamic drive of particles to spontaneously flow from high to low energy states. If a system has a gradient, meaning, a difference in chemical potential from one area to another, that gradient acts as a direct driving force. It physically pushes matter until equilibrium is finally achieved. It's actually super intuitive once you think about it. If you understand gravity, you pretty much already understand chemical potential. In classical physics, gravity pulls mass down hills, right? Water flows down a mountain simply to lower its gravitational potential energy. While in thermodynamics, chemical potential does the exact same thing, just at the particle level. Particles flow to lower energy states to maximize entropy. They're essentially just rolling down a microscopic thermodynamic hill.
So, part 1, powering our modern world and how chemical potential drives our technology.
To really wrap our heads around the scale of this, consider this projection. By the end of 2024, the annual global demand for lithium-ion batteries is set to cross a staggering 1 terawatt-hour. That's enough energy to blow your mind. It's a massive, planet-spanning industry driving our electric vehicles, our electronics, and our power grids. And the entire foundation of this trillion-dollar industry? It's just the manipulation of chemical potential. Because a discharging battery isn't magic, it's just chemical potential doing its thing. In a standard lithium-ion cell, lithium ions are trapped in a super high chemical potential state over in the graphite anode. They desperately want to roll down that thermodynamic hill we talked about, so they leave the graphite and travel to the cathode, which is a much lower energy state. But because the battery's electrolyte blocks the electrons, those electrons are forced to take a detour through your phone circuitry to get to the other side, giving you electrical power along the way. Your phone literally only runs because those particles are desperately trying to flow to a lower chemical potential state.
And you know what? This exact same concept applies perfectly to the computer chips that are processing this very explainer right now. In solid-state physics, chemical potential goes by another name, the Fermi level. A pure semiconductor has a perfectly balanced Fermi level right in the middle of its energy gap, which honestly means it doesn't conduct electricity all that well. But when we dope it by adding specific impurities, we deliberately shift that chemical potential up or down. We're literally manipulating chemical potential at the quantum scale to create the logic gates that run our digital world.
But mastering this is no walk in the park. As we shrink chips down to atomic levels, we hit this massive roadblock called Fermi-level pinning. Basically, surface defects on the semiconductor act like a microscopic sponge, trapping electrons and permanently pinning the chemical potential in one spot, which totally ruins the chip's performance. The cutting-edge solution? Inserting a single atom-thick layer of 2D graphene right between the metal and the semiconductor. This entirely stops the electron trapping, successfully unpins the Fermi level, and lowers the energy barrier to an incredible 0.012 electron volts. It's a gap so tiny that electrons can just breeze right through. This kind of mastery over chemical potential is exactly what's going to save our next-generation logic circuits.
Moving on to Section 2, surviving the climate crisis, looking at water, weather, and ultimately, our survival. So, you've probably heard of osmosis, right? The classic water follows salt rule from high school biology. But the true physical driving force here isn't just a basic concentration gradient. When salt dissolves in water, it increases the system's entropy, which permanently lowers the chemical potential of that water. So pure water actively seeks out that lower chemical potential state by forcing its way across membranes into the saltier regions. Once again, it's that exact same thermodynamic hill.
And understanding that hill gives us the power to actually create fresh water. If nature fundamentally wants water to flow into the salt, we basically have to force it to go backward. Older thermal desalination methods used to just boil the water, which burned through a massive 20 to 27 kilowatt-hours of energy per cubic meter. But modern reverse osmosis, it uses mechanical pressure to artificially raise the chemical potential of the salt water, forcing the fresh water back across the membrane against its natural flow. By fighting the chemical potential gradient directly with pressure, we've managed to drop energy usage down to a mere 3 to 6 kilowatt-hours. That is a real game changer.
But this invisible force doesn't just stop at the ocean. It completely controls our weather. When water changes from a liquid to a gas, like evaporating into the atmosphere, it's all driven by chemical potential trying to equalize across different phases. The math governing this is actually so elegant that Lord Kelvin, the legendary pioneer of absolute temperature, once stated there is nothing in all of natural philosophy more wonderful than any other than the reasoning behind the Clapeyron equation. It's truly a profound piece of mathematics.
So the crucial point here, and why this really matters for us, is what this exact math proves about our modern world. The Clausius-Clapeyron equation mathematically guarantees that for every 1 degree Celsius rise in temperature, the atmosphere's capacity to hold water vapor increases by roughly 7%. That is a massive, exponential jump in atmospheric moisture. Chemical potential is the exact, undeniable thermodynamic reason why a warming planet is suddenly experiencing such extreme and violent climate events.
And just as a fascinating little side note, because chemical potential for a phase change is so deeply tied to pressure, it leads to some pretty crazy real-world quirks. Like, if you were to climb Mount Everest, the atmospheric pressure up there is roughly a third of what it is at sea level. Because of that massive drop in pressure, the chemical potential equilibrium shifts completely, meaning water boils at just 71 degrees Celsius. At that temperature, it would literally take you hours just to hard-boil a single egg.
All right, Section 3. The engines of life, or the biological machines keeping us alive.
Deep inside your cells, you have an enzyme called ATP synthase, and it is, quite literally, a biological machine. Your body uses the energy from the food you eat to pump protons out across a membrane, creating a massive chemical potential gradient that we call the proton motive force. Those protons are absolutely desperate to flow back down to a lower energy state, and as they rush back through the ATP synthase, they physically spin a biological motor, exactly like water rushing through a microscopic hydroelectric dam. That physical mechanical rotation is what stamps out ATP, which is the exact energy currency keeping you alive right now.
But biology is incredibly smart, and it takes this chemical potential efficiency even further. For decades, scientists thought ion channels, which let ions crash down the chemical potential hill, and active transporters, which pump them back up, were totally separate entities. Actually, scratch that. Recent discoveries have revealed transporters. It's a fun word, but it describes giant protein complexes where the channels and pumps physically fuse together. When an ion channel fires, the attached pump immediately senses the change and fires back, rapidly restoring the chemical potential gradient. This lightning-fast reaction is the exact mechanism preventing lethal conditions like sudden heart arrhythmias.
Which brings us to our final part, Section 4, the master key to tomorrow, and why mastering this thermodynamic rule absolutely matters.
We've definitely covered a lot of ground today, from the batteries sitting in your pocket to the extreme weather outside, all the way down to the tiny biological motors spinning inside your cells. Chemical potential is not just some dry textbook theory. It is literally the master key to human innovation. Understanding and controlling this universal conductor is how we're going to solve our biggest engineering, environmental, and medical challenges. We are actively using these laws to design next-generation quantum computer chips. We're optimizing reverse osmosis to secure clean water for billions amid a raging climate crisis. And we're engineering targeted molecular medicines that interface flawlessly with the electrochemical gradients of the human body itself.
We are honestly just scratching the surface when it comes to harnessing the power of this invisible pull. When you look at the world around you now, remember, absolutely nothing is static. Everything is constantly, desperately seeking balance. So I'll leave you with this thought. If this single hidden thermodynamic rule orchestrates the movement of literally everything in the universe, how will our continued mastery of it ultimately shape the future of human survival? Thank you so much for exploring this with me today. Keep questioning, keep learning, and I'll see you in the next explainer.